Welcome to our elevator pitch for IME 450 Fixture Design. My name is Grace Hurley.
My name is Kevin Creel.
So on to background, we are supposed to create a custom fixture that can hold the second CNC operation for the bottle can opener, which will then mount to a horizontal tombstone and will be designed using SolidWorks. Here we have the objectives for the fixture design. First, we design the custom fixture for the second operation. Then we ensure that it's secured and there's repeatable mounting on the horizontal tombstone. Then we use standard fixturing components to simplify manufacturing assembly. Then we create a detailed SolidWorks model. Then we wish to improve machining precision, repeatability, and setup efficiency. Then personally, we wish to gain practical experience in fixture design and CAD modeling, applying GD&T principles, and to apply manufacturing best practices for CNC operations. Then for our solution approach, we will then identify key part and tombstone geometry, then design the fixture in SolidWorks, then validate the design with FEA, then create a detailed drawing with GD&T, then generate CNC toolpaths, then machine the fixture, then test the fixture, then we evaluate the performance of the fixture. Now we have the specifications, constraints, and requirements. First, the fixture base has to be within that size specified on the page there. Then mounting it has to securely attached to the city tombstone. The part location and alignment, it has to be indicated parallel to the CNC machine axes. It must also be located off qualified datums machined during CNC operation 1. The operation requirements, it has to load and unload time must be under 1 minute. Clamping forces must withstand machining forces with a minimum safety factor of 3. The functional requirements is it must not interfere with toolpath, must allow for part removal and cleaning. Material must not fail or deform, must not damage or distort part surfaces. Now the steps taken to design this fixture was we defined the datums and part orientation, then we calculated tooling forces, then we applied 3-2-1 locating principles to fully constrain it, then we did fixture plate layout, then we did CAD modeling in SolidWorks, then we did the GD&T and drawings.
The part drawing on the left gives us our datums and GD&Ts for holes and critical features. The assembly drawing on the right gives us our important parts like locating rail, dowel pin, and clamp, and all the screws necessary to mounting everything to the fixture. When conducting the FEA analysis in SolidWorks, we had a deflection of under 1 thou, and we had a stress that was half our yield stress. The cutting forces was half the clamping, or was a third of our clamping forces, which puts us in a good factor of safety. On our left, we have the toolpaths for operation 2, and on the right, we have the toolpaths for making the fixture. Operation 2 would take about 8 minutes, while the fixture took around 30 minutes. Running a cost analysis, we can see that our engineering time took up most of the costs in the part, with some additional minimal costs in shop time.
For the DFM, we made sure that there was no sharp edges. We used standard parts when possible. The wall thickness was optimal to minimize chatter. We made sure that there was rounded edges internal and external, and all the holes are perpendicular to the top surface.
Finished designing our fixture, we cut the stock down to size and performed our CNC fixture operation. Next, we assembled the standard parts in with our fixture and torqued down the clamp to our plate and made sure everything was secure. After this, we ran operation number 2 to test that our fixture would hold the part successfully. Originally, during testing of operation 2, the part was thrown off. To fix this, we added 2 washers in between the clamp and the part. This prevented the part from flying off the fixture. In conclusion, we were able to perform operation 2 and get a successful part. We were able to have tool paths that did not collide with any of our components. We had a setup time of under 1 minute, and our clamping forces were stronger than our cutting forces with a safety factor of over 3. And a note to future designs that we will move the clamp location closer to the part.